Alright, at 2.2, polynomial functions of higher degree. This section is all about exactly as it says, how to deal with polynomial functions with degrees that not necessarily are quadratics. I mean, third, fourth, fifth, sixth powers, and we're going to start right into it. We have y equals negative x to the fourth. Now, when you see x to the fourth, you're thinking it's going to be similar to your x squared graph. What's your transformation that's happening here, though? Your transformation that's happening is that's reflected over the x-axis. So instead of it being up and up, we'll draw some here. And then instead of it being up and up, it's going to be down and down. Now with the x to the fourth graph, the difference between it's on a parabola. It kind of takes a minute to start to decrease suddenly, right? It's very slow, like it's slowly decreasing. That's when boom, okay? Right around when it hits, because of course at x equal to 1 and negative 1, it's going to be 1 even if it was x squared x to the fourth. But then once as it starts to increase, get more negative or get more positive, then it's going to really shoot down. Y equals x minus 1 to the fifth. That's going to be a shift to 1 right. And x to the fifth is going to be similar to the x to the third graph, right? X to the third, remember, is that little squiggly line, right? Does one of these. Like that. Now, similar, it's going to slowly increase, not a little bit more so than the x cubed, then it's going to shoot up quick. Slowly decrease and shoot. Okay? Something along those lines. So this is a nice little chart for the end behavior of a polynomial function. A good way to tell. These top parts, when I say n, I'm referring to the highest power in your polynomial, okay? So whatever that is, that's what it's referring to. So if n's even, you're living in this column right here. If n is odd, you're right here. A being the leading coefficient. If that's positive, you're in this row. If A is negative, you're in this row. Okay. So how this reads is as x goes to infinity, meaning as x gets bigger and bigger, what's your output going to be? It's also going to go to infinity. So that means as we go further right, when n is even and A is positive, as we go further to the right, it's going to go to infinity. As x goes to negative infinity, as we go left part of the graph, it's also going to go to infinity. So that's how you read all four of these different boxes here. We're going to do some examples where we're going to be applying these. Feel free to pause the video to jot these down so that you have them at your disposal as you are practicing these. You will be expected to know this. So let's find the end behavior of these two polynomial functions. So first one up top here, what we got an even and we got a negative. So even and negative, so as color, as x goes to infinity, f of x will be going to negative infinity because it's even and it's negative. As x goes to negative infinity, the output will also be going to negative infinity. Even, remember, look at your even and negative. Now, for this one, we have odd and we have positive. So therefore, since we have odd and positive, when x is going to infinity, f of x is also going to infinity. As x is going to negative infinity, f of x is going to negative infinity. Because it's odd and we are positive. Alright, so there are four different ways that we can write our real zeros of a polynomial function. So real zeros, there's four different ways I can say it, we can write it, depending on what's being asked. One first way is x equals a is a zero of the function f, of function f. Second way, x equals a is a solution of the polynomial equation f of x equals 0. We can also say x minus a is a factor of x minus a is a factor of polynomial f of x, whatever f of x is. And then finally, for fourth way, a comma 0 is a x-intercept of the graph of f. Right? If I'm asking for your x-intercept, it's usually written as whatever that 0 is, comma 0. So let's find all the real zeros and let's sketch the graph of this. This is where we're at. We're going to do a few of these. Let's factor out these out. So we factor out t. We're going to get t squared minus 8t plus 16. Keep going. Factors of 16 up to negative 8 is t minus 4 times t minus 4. So when we graph this, a few things we need to keep in mind. We have technically we have two zeros. 0 and 4. 1, 2, 3, 4. Ha. And what is, using the rules we had previously in this video with end behavior, as t increases, what's happening? It's going to go to infinity, so it's going to shoot up. When t goes to negative infinity, what's going to happen? It's going to go down as we go to negative infinity. Now, what's happening between here? Well, at t minus 4, we have what's called a multiplicity of 2, because we have 2 of the same factor. So at 4, it's going to go back up and kind of form what's going to look like a parabola, and eventually come back down. Now for this one, I see a GCF of 3. Going to leave me with 3x to, I already factor out the 3. And then that's going to leave me with x squared plus 2 times x squared plus 1. Well, this is unfortunate. We're not going to have any x-intercepts because they're all going to be imaginary. So in that case, let's just draw what we can. We know the y-intercept is at 6. And we know it's going to be an up and up function. So vertex is there too, so it's going to do one of these. Up and up, not touching the x axis at all. Okay, so we're going to sketch the graph of this function, apply the leading coefficient test, find the zeros, and plot some points in between. So, leading coefficient is going to be -1 and to the third, so it's going to be odd. So it's going to be up and down. So as we go to negative infinity, it's going to go to infinity. And as x increases, it's going to go down to negative infinity. Finding the zeros, I'm going to factor out negative x squared. And then it's going to get us x plus 5. And that's going to get us zeros of x equal to 0 and -5 with a multiplicity of 2 for the 0. And now time to plot. 0, 0, and 2, 3, 4, 5. And then from there, we are going to, as we said, it's down and up, so it's going to be down, or other way around, up and down. So I'm going to do one of these. Let's plot some points in between. If we put in -3, we're going to get -9 times 2, which is -18. So somewhere down there. And then if we put -2 in, it's going to get us 4 times, -4 times 3, which is 4 times, -4 times 3, which is -12. So it's going to go up a little bit. So it's going to go one of these, right? And there's what our graph's going to roughly look like. I appreciate you watching. And last thing we're going to do when we meet in class is find the polynomial given zeros. Okay? So we'll do some practice with that. Take care. We'll see you later.